So in this video, we're going to talk about how to use temperature, which is the measure of a sample's thermal energy, how we use that to calculate the overall heat, or Q, for a sample. We talked about in the previous video that a substance's heat can be reported in units of joules or calories or kcals. Now we're going to talk about the equation that is used to calculate that overall heat. And that equation involves three different variables. The first being the mass of the sample. The second being the temperature change that sample undergoes. And the third part of this equation for calculating a sample's heat is this variable called specific heat. Specific heat, we use capital C, sometimes small c, to designate that quantity. But that constant for each substance reflects how some substances heat up faster than others. So when multiplying a substance's mass and its specific heat and the temperature change that substance undergoes in a reaction, that will give you an answer that reports the overall heat that substance has gained or released. So Q equals mc delta T. That equation is going to be important for this video and for the subsequent videos when we do practice problems. So you're going to be using this equation a lot. You're also going to be using this equation not just to solve for heat, but to solve for these other variables as well, Q, M, C, and delta T. And so we'll do practice problems where we use this equation to solve it for each variable. But before we get to those examples, let's talk a little bit more about specific heat, that C, that variable C that was in the equation. We said that it reflects how much heat is necessary to raise the temperature of a substance, either a gram or a Kelvin unit. So I have some subs in this table here that's also in your textbook. I have some listed substances and they're listed heat capacities or specific heat capacities. And you'll notice a few things here. When looking at the units for specific heat capacity, the units are kind of funky in the fact that they are derived units. They're units like density in the fact that there's a unit in the numerator, in this case joules, and in the denominator there's the product of two units, grams and degrees Celsius. This unit for specific heat capacity is just a reflection of how this quantity is measured. So don't let the fact that there's a unit in the numerator and a unit in the denominator concern you. That is the case for specific heat capacity. So that's the first point to make, is that units for specific heat are generally in joules per gram degrees Celsius. Also, like density, specific heat capacity is an intrinsic property, meaning it is specific to the kind of material you are dealing with, and it's independent of how much substance you have. It doesn't matter if I have a gram of iron or a kilogram of iron. My specific heat for iron is 0.449. So therefore, we can use specific heats to help identify what a potential substance is. And I guess the last point to make about this slide is that the greater the specific heat capacity of a substance, that means the more heat is needed, the more joules is needed to raise the temperature of that substance 1 degree. So you can see as water, with the highest specific heat out of all of these that are listed, it's going to take a lot more heat to raise the temperature of water 1 degree than it will ethanol or anything else. That's why it usually takes a long time for water to boil, because water has a high specific heat capacity. Now, why that is, we'll talk about much later in the course. But the fact that a watched pot never boils, or it takes a long time for water to boil, is a reflection of its high specific heat. One more note about the Q equals MC delta T equation before we start talking about some examples. We said that delta T portion of the equation meant change in temperature. So when you calculate the change in temperature for a substance, you always want to do the final temperature minus the initial temperature. So let's do this example. And in the next two videos, we'll be doing plenty more examples. But let's say I have this question. And it says it took 73.2 joules of heat. So I already see that in my problem, I'm given a quantity in joules. So I'm given some heat. It took that amount of heat to raise the temperature of 10 grams of a substance 8.58 degrees Celsius. What is the specific heat of the substance? So I have a Q. I have a mass. I know this is a mass. This 10 grams is a mass because of the unit. So I have a mass. I'm given the change in temperature. It raised the temperature 8.58 degrees Celsius. So I have a temperature change. And I want to know what the specific heat is of the substance. So I'm going to be using my equation Q equals MC delta T. Right now, that equation is solved for in terms of Q. I want to solve it in terms of C, specific heat. So you remember the opposite of multiplication algebraically is division. So to get this variable C on one side of the equation and everything else on the other, I have to divide both sides by M times delta T, which is what I've done here. So the specific heat, C, is going to be equal to my heat divided by the mass times my change in temperature. And so when doing that, when plugging my numbers in, this is what you get. And I see that none of my units cancel, which is good because we said specific heat is in joules per gram degree Celsius. So when doing 73.2, and then you want to divide by the product of 10 times 8.58. And the answer to three significant figures that you should get is 0.853 joules per gram degree Celsius. So that is one application of this Q equals MC delta T equation. In the next two videos, we're going to be doing some more practice problems using that equation. I'm going to try and watch significant figure rules throughout it, but I'm not going to be as concerned about significant figures when reporting your final answer. What I'm going to be looking at when you do these problems is I'm going to be looking at the fact that you can set it up, know which variables go where, and then being able to report the answer correctly.